Let's take the derivative like it was suggested with respect to x. You got it yesterday. Yes. They are all over on the table. I don't know what's wrong with it. Hurts pretty bad. So you see me correcting my left hand. But that's okay, because remember I broke my arm last year, so.
Yeah, I heard that was really bad.
I broke it, I broke it. It was pretty bad. No, not considering I hadn't done it. What's the derivative of 6? 0. So the 6 is gone, Justin. Justin, what is this going to give me? Because you're not paying attention.
Over x squared.
Only if you prepare for it is it easy. Equals 2. Now the square root of x. Well, it's 1/2 x to the negative 1/2. You're going to find some tricky integrals today. Over x squared. You'll regret that, let me tell you. And then this is 1 over the square root of x. So I'm going to multiply by x squared. So what's f of x equal to? Is he right? True, but you have to take the little quiz. Because there's no count. No, it's marked 0 missing. It's missing. Okay, any problems with that? No? Okay, we are going to do use substitutions. We know how to do this. We're looking for some sort of function here, and we're looking for the derivative of the inside function, composite function. And so I do a use substitution to see if I can figure it out. Times the derivative of the upper limit. Yes. So what do you want you to be in example 1? That one's not too bad. Somebody want to come up and do this? Who wants to come up and do it? Either way will work. Because my thumb is hurt. It's all swollen. So what's du equal to? And you really have to have that differential, because you're accounting for everything in this antiderivative. So I don't have a 4. So what do I have to do with this? Divide by 4. Now when you substitute for everything. So let's see what I've got here. I've got an x cubed and a dx. That would be this piece. So that's 1/4 of du. And I'll put du over here. And then what's this going to be? It's the cosine of u. Oh, that's not too bad. So that's equal to 1/4. Is it negative or positive? It's positive, isn't it? How do I know? Take the derivative of x to the 4th plus 2. And what needs to be added to the end? Plus c. Okay. Actually, you're better off not. Don't put a box around your answers, because if you do, then we take that as the answer. Later on, you come back to it and say, oh, that wasn't my answer. Here's my answer. Well, we won't look at the, here's my answer, because we go right for the box then. So don't do it. Not recommended. Cross things out, yeah. I prefer them too, but the recommendation is not to do that. Okay, what about this one? The next one's going to get harder. So du is equal to 2 dx. So dx is equal to 1/2 of du, right? If you notice, I gave you some hints on 5.5 and handout. So this is the integral of u to the what? 1/2. I have to put my du in here, and so what's going to go out in front? This 1/2. So we're going to anti-differentiate that. What's the antiderivative of u to the 1/2? U to the 3/2 divided by 3/2, but that's the same as multiplying by 2/3 plus c. And then we'll cancel out the 2's, right? So it's going to be u to the 3/2, so it's 2x plus 1. We're supposed to get rain. But if it freezes, depends on what the temperatures do. There it is. Okay, you ready? Sorry. Look at ice. Ice is even better.
No, because I think it's salty. I think it's salty before and
That's what I'm saying. Ice is good for a snow day. Okay, ready? There's a senior snow day? No. Okay, you guys. Okay, you guys, you smarty pants. How are you going to do that one? Then what is du? There's the problem. Well, I can do that, but I'm going to have a sign in there. What do you want to do? What? We can, but then you're going to end up with u cubed, and dx is du divided by negative sine of x. What's the problem with that? And Justin, since you're in multivariable, can we do that? Too many variables. When you go to multiple variables, you're going to have a couple integral symbols, and you're going to have 2 differentials. So that's not going to work. Then the derivative would be, then du is equal to 3 cosine squared of x times the derivative of cosine, which is sine of x, dx. That looks worse, doesn't it? You're going to have this. dx is, you're going to have, let's see that, you want that to be u, so that'd be u. And then this would be 3 cosine squared of x times the sine of x. That looks even worse.
is that right or wrong?
I don't know how to do that, do you?
We can't do it.
You can't do it that way.
No, we can't do it.
You guys are not going to be great, whatever. What? Maybe, but right now we're going to learn how to think a little bit. How about if we write it this way? Okay, I haven't done anything earth-shattering yet, but what about cosine squared of x? What's that? There's an identity. 1 minus sine squared of x. Oh, this one you have to know. You have to know this one. There's two you have to know. Sine squared of x plus cosine squared of x is equal to 1. That's 1. What about the sine of 2x? No, it's 2 sine of x, cosine of x. So if you look on your handout, that extra hints, that'll help you with some of these problems, because these are not easy problems to integrate. And as long as you don't have a CAS calculator, you have to do it. Yeah. Okay, so let's rewrite this. It was cosine cubed, so it's cosine squared is 1 minus sine squared of x. And we still have a cosine there, which is good. Whoops. Oh, that'll work. Cosine of x. Can I go ahead and distribute that? I'm looking at it, thinking maybe there's two ways to do this. But maybe the easy way is to go ahead and distribute that, because that's going to give you what? Cosine of x dx, because you can do that with integrals. You can distribute those, which is nice, minus the integral of sine squared of x times the cosine of x dx. How about that? I know how to do the first one. I don't need to use substitution on the first one. What is that? No, I just need one. You'll see. What's this going to give you? Not sine squared. This is going to give you sine of x plus, and you want u to be sine squared? That looks complicated. If I just let u equal the sine of x, that's going to be easier. Pardon? This is the only u substitution I'm going to do. Cosine of x dx. And I'm going to account for everything. This is u squared, right? And cosine of x dx is du. Good, I got rid of all the x's. Except this minus. And so it's the integral of u squared du. So now we can do this one. Whoops. Okay, so I got the sine of x minus u cubed over 3, right? Plus c. Yes, you should be beating me at this since I'm writing with my left hand. So the sine of x, what was u? That was the sine of x, right? And I do the u substitutions because I can't always see what is happening. And there's a whole course that you may end up taking on finding antiderivatives, especially with trig substitutions. It's a separate course. You may not be taking it. I mean, I don't think we are offering it here. It'll be a separate course. It'll be techniques of integration. Yep. I don't know what's the answer, right? That's 4. Yeah. Did I miss example 3? I don't even have example 3. Oh, I know where it is. I'll bet it's underneath this. Sometimes that happens. Oh, this is easier. What about this one? And by the way, though, even though it's easier, it's often missed. What would you like u to be? And yes, u substitutions are on your quiz tomorrow. Okay, Justin? So u equals what? Yes? On 5-1 through 5-5. That's pretty big, no. Thursday we'll give you back your quizzes and you have a work hour.
cool, so I can do my stuff. Wait, so why was why would I work over tomorrow?
Because you're going to go to the hockey game tomorrow night.
Yeah. It's not like we're going to study close.
That's exactly what I said to Mrs. Ersman. I said, well, it doesn't matter. I said, you guys can choose, actually. Take the quiz Thursday if you'd rather. So what are we going to do? Not that one. We didn't do that one. The cosine cube? Never did that one last year. These. But you know what? I see you guys getting this wrong, even though it's pretty easy. What am I going to put here? 1/5. Well, it's the cosine of u, and then dx is 1/5 of u. Oh, that's not too bad. But, you know, you'll mess up with 5. It's the cosine, whoops, forgot to anti-differentiate. Oh, I've seen that happen too, lots of times. Sine of u, but that's 5x, right? Plus c. Okay, ready for the hard one yet? Are we okay? That was trig, but this next one's not trig. This makes you have to think back a little bit. Not tangent. It's not x squared plus 1. It's x squared plus x. You can. Anybody remember how to separate those, Kevin? You can, but you can't write 2 integrals. There's only 1 integral. You're gonna groan when I tell you what you have to do. Matt, you remember? Justin, you haven't know. Justin, you don't know how to do this either. Good, figure it out.
Good, right now.
Matt, how are you gonna do this?
I thought I could solve it right now. Do it up on the board right now then.
Oh, partial fractions, Justin. Do you remember partial fractions? X times x plus 1, because you can't integrate that, equals, well, we have to undo the adding of these fractions. It was some number over x plus some number over x plus 1. Well, on the multiple choice part of the exam, you could take the derivative of all the choices. You could do that, but it's not that bad to do this. What do we have? Now, what are we going to do? I want to find out what A and B are, but what are we going to do first? Okay. Guys, Kevin, Justin, the door's there. Multiply by what? X times x plus 1. Yes, we did. This is a p-series, but it can be integrated. It's a collapsing sum, remember? Oh, it's not that bad. So, no, because actually these are easy. This is 1 equals 100%. Yes, they do have partial fractions on the VC exam. You might even see some tomorrow. Plus b times what? What cancels? Yeah, let's cancel. Now, do you remember the trick that we did here? We want to find out what a and b are. X is any number you want it, so x is equal to 0. I cleared out the fractions. So 1 is equal to a, right? If x is 0. And what's the other nice choice? -1. So 1 equals, well, the a is going to go away because that -1 there. Negative b. So this is going to end up being this. So it's 1, let's see, it's a over x. A was 1. Guys, go out in the hall. Over 1 over x plus 1 dx. We're not done. How do you do that now? It's the natural log of the absolute value of x minus. So when I get these partial fractions, yes, but the problem is on the exam, it's not going to look like that. They're going to use properties of logs and change it. I know because I've seen it. So it's the ln of absolute value of x over x plus 1. And you guys know that that can be written as the absolute value in division can be written as the absolute value of the quotient there, plus c. So you can write it this way. I think so. Yeah. Okay. Ready? Okay. This is just the substitution rule. Oh, we better do this. Hey, you guys. Shh. On the exam, another thing that they're going to do is have you do the substitution, the u substitution. And you'll just set it up, but you won't find the antiderivative. Okay, so we got to make sure we remember that. What would you like u to be here? We're just going to set it up. We are not going to integrate it. So what's du? Be 2 dx. So I'm going to have the antiderivative. What's going to be out in front? 1/2. And then this is going to be u, or the square root of u, right? du. So on the exam, the first choice is going to be this. Look through your answers. I haven't finished yet, have I? Here's another choice. I am not done. I'm not done. Hang on. You're going to see, no, it's still not done. I have to put the numbers in. You guys, the door is over there. If you're not interested, then you shouldn't be here. Okay, I have to put the numbers in. B is wrong. B is wrong because what do these numbers represent? Those are x's. Okay, so we have to switch it over. Now what happened in AB is some of the kids switched it over, did it really nicely, then they went back to x's, but they used the new u values as their x's. I'm like, no. Okay, so when x is 0, what's u? U is equal to 1. I just substituted into u equals 2x plus 1. When x is equal to 4, yes, u is equal to 2 times 4 plus 1. So it's equal to 9. So it goes from 0 to 4, so it goes from 1 to 9. And you know that C is going to look like this. It's going to be 1 to 9, and it's going to be the square root of u du. And the final answer, D, might be where the correct answer is. But see how they distract you with these other options. You may see 3 of these. Be interesting to study the AP exam. 3 of these was the 1 to 9, and 2 of them was 0 to 4. They still can't, I wouldn't make a bet on it that they may only have 2 of them with 1 to 9 and 3 of them 0 to 4. For your guessing on this stuff? On this stuff? 5, 1 through 5, 5. 5. Oh, that's not the right answer. D is 1/2, 1 to 9, square root of u du.
I remember that. So that question always takes.
Not necessarily, but do be careful because there was one problem where one of the right answers was in A, but it wasn't the whole thing, and they threw that one out in 2008. Yeah, you could do a lot of intelligent guessing. I just used. Oh, and one last thing.
The last one, there's also one right next to it.
Did I hide one again?
You don't do the first, the last four, the middle.
Whoopsie. Oh, that's a nice one. Oh, I'll bet it's hidden under here.
I have to talk about that. And I don't do it.
No. Okay, guys, how are you going to do this one? No. U is equal to the natural log of x. The only ones you have to know are on that blue sheet. Then what's du? 1 over x dx. It's not right without the differential. Not to say they're going to mark it wrong, because they're not going to mark it wrong. So we have too much to look at. So this is the integral. This is u, the log of x. And the dx over x is the du. Now what are the u values? If x equals 1, then u is equal to the log of 1 is 0. And the other one's e. If x is equal to e, then u is equal to the log of e. It's so much easier. I think it's easier to do these and change the limits of the integration right away and just be done. It's more work to have to go back to x's, but you can if you prefer. Do I need to finish it? Well, you would normally. Now, all that's left are the properties of the symmetry one. So if you have an odd function or an even function, it's really easy then. So if you have an odd function, the integral from minus a to a of an odd function, no, that's 0. What if it's even? I can't get the even one any easier than that, but it does help usually to have a 0 in there. Okay, I'm going to run and get a worksheet, some problems for you guys to do. Because if I don't, you won't do them.
Wait.
Yes, if you have an even function, you can just double it. Yeah, I'm just going to turn this off.